So now that we've talked at length about a use case of reentrant or recursive mutex semantics, let's take a step back and look at some of the key methods that Java ReentrantLock defines. And the key methods here are ones we've talked about. They're what are inherited or implemented from the lock interface. So it's lock, LockInterruptibly, tryLock, and unlock. So let's talk a little bit about these. Again, all these things come from the lock interface. All the methods defined here simply forward to the implementer methods, which largely inherit from abstract queued synchronizer. So once again, that's a great example of systematic reuse, and very, very systematic reuse because the abstract queued synchronizer is used in multiple places. The lock method acquires the lock if it's available. If the lock isn't available, then what happens depends on the fairness policy that was selected, either fair or non-fair. Non-fair implementations are optimized in hardware using these atomic compare and swap operations. And so it really is up to the system to decide what to do. Fair implementations will park the waiters on a wait queue in FIFO order. So that's the difference. So non-fair implementations are optimized. They may spin, they may do whatever. Fair implementations park themselves in FIFO order. The lock method is not interruptible, which mirrors the same semantics for the built-in monitor objects. So the synchronized keyword is also not interruptible. Conversely, LockInterruptibly acquires a lock unless it's interrupted. So as you can see, it throws the interrupted exception, and this gives you a different, perhaps more flexible range of semantics than we get with built-in monitor objects. Built-in monitor objects are somewhat limited, but ReentrantLock goes further and allows you to interrupt these things. tryLock, which is what we looked at before, we actually looked at the implementation of non-fair try acquire. It will acquire a lock only if it's not already held by another thread when the call is invoked. So when the call is invoked, then it will check to see if it's available, and if so, it'll grab it. Otherwise, it will return false. If it gets it, it returns true. Otherwise, it returns false. The untimed version of tryLock, and this is the same as for the semaphore try acquire method, untimed version, doesn't honor the fairness setting and therefore can barge, meaning it cuts in line. Unlock attempts to release the lock, and if the thread that is calling the unlock method is not the one that holds it, then an exception will be thrown. And I should also have pointed out that lock and LockInterruptibly are reentrant, of course, as is tryLock for that matter. ReentrantLock is fully bracketed, so the thread that acquires it must be the one to release it. If the hold count is greater than 1, then the lock is not released. It just simply decrements by 1, and it'll continue to own the thread that's unlocking will continue to hold the lock. Believe it or not, there's a whole bunch of other ReentrantLock methods. Now we're going way beyond what's in the built-in monitor object synchronized method and statement. There's a whole bunch of other methods, and they are going to be things that can do timed acquisition of a lock. This one does honor the fairness setting and therefore cannot barge, unlike the untimed version, which can barge. Is fair simply returns whether or not the lock has fair or unfair semantics. Is locked queries the lock to see if it's currently in use, currently locked by some other thread. Not the world's most useful method because by the moment it returns a value, it may already change because of the non-determinism of concurrency. That's just the way it is. And then another method, which is very important, is called new condition. And this returns a condition instance intended for use with this ReentrantLock. And we will talk more about that when we get a little further down the road when we talk about condition objects. Don't worry too much about that right now. So that's the end of our overview of key methods in Java ReentrantLock.